This is Pre-Calculus Onramps, Unit 5, Test Review. I'm going to do questions 5 through 8. This one is a graph. Given this piecewise function, evaluate the following statements. Write D and E if the limit does not exist. So it's asking for a bunch of limits. So the first one says the limit as x, I'm trying to get this in the screen here, x goes to -2. Well, I can see as it goes to -2 from the left, it approaches x, -2 from the left, it goes to y equals 4. And as it approaches from the right, it goes to y equals -2. So since the one-sided limits are not equal, it does not exist. All right, what is the limit as x approaches 0? It approaches 3 from both sides, so that one is 3. Actually, let me get rid of that stuff, that drawing, so I can see what I'm doing here. As x approaches 2, I can see that as it approaches 2 from the left, and as it approaches 2 from the right, the value it approaches is -1. Let me zoom in a little bit just to double check that. Yes, -1. And then f of 2 is equal 3. See how there's a hole at -1? So f of 2 equals 3. So the limit could exist and yet not equal the value of the function. As x approaches 4, well, it approaches infinity from the right, negative infinity from the left. Even if it approached positive infinity from both sides or negative infinity from both sides, that's still a does not exist limit. Infinity isn't a number. As an x approaches infinity, as it goes further out, it looks like it approaches 2. Y equals 2. F of x equals 2. So that's number, whatever that was, 5, I think. Okay, let me check out number 6. 6. 6. Okay, find each of the following limits algebraically if it exists, right? Do not exist, does not exist. So if I put in 5, I'm going to check denominators because if the denominator is 0, I have to do factoring probably. 25 times 5 is 25, minus 6 times 5 is 30. So 25 minus 30 is -5 plus 5 is 0. So let me try some factoring. I'm going to multiply 3 times -25 and find numbers that multiply to -75 and add to -10. Let me think about this. 5 and 15. Yes, 5 and 15. And the 15 has to be negative. So I'm going to put x minus 15. I'm going to put that 3 underneath the 15. And I'll put x, what was it? Plus 5 over 3. And 15 over 3 is just 5. 5 over 3 can't be simplified. So this is x minus 5. And I'll put this 3 back over by the x. 3x plus 5. And then in the denominator, x squared, I want factors that add to 5 and multiply to 5 and add to -6. -5 and -1. How about that? X minus 5, x minus 1. Now notice that x minus 5 canceled. So now maybe this is going to work. If I put 5 in now, 3 times 5 is 15 plus 5 is 20. 5 minus 1 is 4. 20 over 4 is 5. So see, some factoring made it work. So if you ever find 0 in the denominator or 0 over 0, try to do some factoring and see if you can make that work. In this case, I think the top would have also been 0, so it would have been 0 over 0. But as soon as you find 0, just factor it. Factor it just to start every one, just to make sure. All right, 3x, I already know what this is. It's the same as the one above. So this is x minus 5. And 3x plus 5. I guess I could just plug in -5 and see what happens. But it might even be easier to do it this way. X squared minus 2x, I'll factor out an x. That's x minus 2. So I put x as -5. -5 minus 5 is -10. 3 times -5 is -15, plus 5 is -10. -10 times -10 is 100. Divided by -5 times -5 minus 2, which is -7, which is 35. So it is 100 over 35. So see, I could have just plugged it in. This made it easier anyway. And what goes in those? 5 times 20 is 100. 5 times 7 is 35. So 20 over 7. And then the last one, let's see, as it goes to infinity, Well, if it's going to infinity, all I have to do is look at the largest power of x, which is x squared. And both of them have an x squared, so I just take the coefficients of those, 2 over 3. Really, what I'm doing is I'm dividing each term by x squared, and if there's any x's left in the denominator, it's going to pull it down to 0. So x squared over x squared is 1, so that leaves me with 2. X over x squared, since it's going to infinity, that's going to be 0, so that goes away. Minus 9 over x squared, that's going to go down to 0, so that goes away. So anyway, it's just the coefficient of the largest power of x. So 5/27 and 2/3. Oh, I'm not done. Wait a minute. That's 6. I thought I was done, but I have to do 7 and 8. 7 and 8, 7 and 8, 7 and 8. Okay, here's 7. Use your analytical skills to evaluate this limit. Well, on top, I have 2 fractions, so I'm just going to cross it and then use the whole thing as the denominator. So 3 times 1 is 3, plus 1 times x minus 3, plus x minus 3, divided by 3 times x minus 3, all divided by x. 3 minus 3 is 0. This is x over 3 times x minus 3, divided by x, which is multiplied by 1 over x. The x's cancel. This is 1 over 3, x minus 3. And now I can plug in 0 for x. 3 times 0 minus 3 is 3 times negative 3 is negative 1/9. So this is negative 1/9. That's number 7. Let's check out number 8. Let's find out. How fast does f of x changing at 15? Use the interval 10 to 20. So I'm going to estimate it. So I do the second part, the value of the second one, 54, minus the value of the first one, 104, the first point. So 10 is the first point, x equal 10, x equal 20 is the second point, divided by the x's. The second one minus the first one. So 54 minus 104 is negative 50, 20 minus 10 is 10, negative 50 over 10 is negative 5. So its rate of change is negative 5. That's the estimate. I'm using how fast is it changing at x equals 15. I'm using the interval 10, 20 to estimate that. That's it. 5 through 8.